So, let's start using the. So today we are revising the topic graph and as a graph algorithm. Algorithm. Okay. In graph, as we know, the graph is a non-linear data structure. It's just like a tree data structure. The limitation of the graph is that it can only represent hierarchical data. For the situational where nodes or vertices are randomly connected to each other, okay, and we use graph. For example, where we use graph data structure, social media networking, computer network of location using GPS, and many more. Example where the different nodes or vertices are connected without any hierarchical constraint. So there is a basic timeline. So we are knowing mm, basic. After that, we have move forward for DFS and BFS, DFS and BFS. After that, DFS, BFS, there is a problem on cycles. Basic DFS, BFS, and we have to note how cycle detection, directed, undirected, and this. After that, we reach for the next topic, shortest path. Okay, completing shortest path, we move forward for the MST, minimum spanning tree. MST, minimum spanning tree, important, but after it is important one, topo sort, topo sort, topo sort, and completing topo sort, we move forward the connectivity in a graph. Connectivity, 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 connectivity in graph. Okay, connectivity in graph, and lastly, some miscellaneous problem. So let's start. Opening the Canva. So moving forward for the code section, right? Code. So let's see basic of BFS, BFS and BFS traversal. BFS means that graph traversal algorithm will start from the source node, explore the level wise. So BFS is stand for the bit for first. Bit for first means that um, search backward, SCRH, and these are level wise, level wise. So level wise searching. So we move to visit the adjacent node and the process continue until the resolve node. Okay. For example, a graph is given 1, 2, 3, 0 is connected to 1 and 2. Like example is given. So how we apply the BFS algorithm. So BFS for the given source in undirected, the algorithm start with the given source of the vertex and explore all the vertices reachable to that source, visiting the nodes in increasing order. If distance from the source level wise using queue, since the graph may contain cycle, the vertex could be visited multiple times. To prevent the revisiting, we track using a visited array. So as a code for writing the BFS. BFS code will be the BFS code will be like this. Code look like BFS code look like this. So BFS return the all the nodes so in a vector form. In a vector form, so will be vector of int of BFS. So what we have vector of agency matrix, so vector of integer at the adj agency matrix. Okay, agency matrix. We have to find the size of agency matrix adj dot size through which loop will be run. Okay, and create a visited array to keep track of the visiting the nodes. We have to keep a track if a node can't be visited more than one. Okay, more than one. So vector of Boolean condition visited, and size will be the size we define earlier with all the initially all are initialized with the false, and after int we initialize a vector where we store our all answers. Okay, let's start. So create a queue in which create a queue. Okay, and the source start with zero index. Okay, zero. So visited of source as RC source is equal to true. Mark the source as a visited. So and q dot push the source. After that after that we run the loop inside the queue. So while queue is not empty. Okay. So check for the take the front node q dot front and front and pop it out. Q dot pop and check put into the result portion. Push back whatever current value and check now check for visit the all the unvisited array and check for the neighbors. Okay. So um, for auto it of region, let's see what will be current one is not visited. If the node is not visited, so we have to mark as visited and push into queue. So mark visited of id is equal to true and q dot push into queue. Okay, and after that we have to return the result. Return the result. So this is how we uh, run the BFS code. Okay, BFS code is simplified and it has time complexity. So discuss about the time complexity. The time complexity of uh, time complexity. Time complexity of BFS will be order of time complexity equal to order of vertex plus edges. Okay, the space complexity will be same as all the vertices are stored in any string, so the complexity will be this. If the disconnected or undirected graph will be there, nothing, and disconnected or undirected graph will be there. So same, nothing extra things are needed. Rule visited, check for the each of element 0 to be visited or not. If visited, so run. For the unconnected graph, just one thing for the unvisited graphs, so undirected graph, only the thing you have to do to int I is equal to 0 in the section I less than b I plus plus. Then the loop for the all check every element. If not visited, source is not visited of I, then we run the DFS code. DFS code. So density matrix I and visited and the result portion. Okay. Then after we have to return the result portion. Okay. And active graph same application shortest path finding. So DFS portion will be cover here. Let's move forward for move BFS cover. DFS is same as we studied earlier. Recursive approach. First of all, we have to mark as true, result in push, finding for the neighbors, finding for the neighbors. If neighbor is not weighted, they recursively call the answer. Okay. Undirected for loop. If not weighted, then the DFS code effectively. So BFS and DFS covered. And difference between BFS. So rodent tomato is one of the prime example. Islands in a graph example. Flood field. Let's discuss the one of the flood fill example. Flood fill, flood fill problem. So rectangle, check flood fill, flood fill algorithm. In flood fill algorithm, what we see, what we have, what we have, a given given is given a density matrix 2D grid. There will be coordinates. So starting row, starting column representing the starting pixel. So a new color where the represent a new color to apply, we perform the flood fill on the image source. It means that we make changes the starting pixel to other pixel if are connected. The two pixel are considered to be this. So if they are connected, color them all. So 2 2 2. If they are not connected, remain same. Simply the approach will be either we use D 0 1 1 1 1 1 0 1 0 0 0 0. So we have to, if they are connected, if this portion is connected, to change the color. If those this portion are connected, change the color. So it become 2 2 2 and this become 2 2 2. So final result will be 2 0 0 0 2 2 2 2 0 2 0 2. So this will be the final output. So how we write the code? Let's start. So flood fill problem. Flood fill algo. Okay. Here is the code. So flood fill problem start with the little vector, vector in which answer will be written. Int of flood fill, flood fill in which we have given 2D vector, vector of integer type as in identity matrix. Okay. His name, this time his name is image, and will be given as starting row, starting column, new color, new color. Okay. So how we write? So how we flood fill? So if first condition, if our image starting row and starting column is equal to new color, so we do not change, return the image. Okay, return the image. Okay, and the old color, call the DFS, the old color will be stored in this int. We have to store the old color and then check. Old color will be stored in old color will be stored in a uh, image of s and column. Old image I stored and run the DFS code equal image starting row, starting column, old color and new color, new color. We see old color, change will be new color. Okay, and then finally we have to return. Then finally we have to return the image, return the image. So okay, let's write the proper algo for the flood fill. So void DFS, DFS in which we have image source and old and new color. And this portion are same. So we have to write on this same source and this there will be int old color. Okay, and the color is given. So run the referencing code. So first, if check the condition, if the new row and column are valid or not, it is written as x and this one is written as a y. So if check the valid condition, if x is less than 0 or if x